For this video, I'm going to be going through the working out for some of the questions for session 4's experimental probability questions from MathSpace. Now, this is not exactly the same view that you would see as students, but it's going through the same style of questions that you will be viewing. Remembering your questions will change slightly with the numbers and so forth, but the structure of the questions will be somewhat similar. So let's have a look. First question here says, to prepare for the week ahead, a restaurant keeps a record of the number of each main meal ordered throughout the previous week. Part A says, how many meals were ordered altogether? Now, this is a fairly common start of a question because remember, with probability, we need to know how many of the thing happens in total and then how many of those options are favorable for us so that we can find a probability. So if I just simply take my calculator and add up those values, so I've got 33 plus 43 plus 21 plus 52 equals, now really my working out should be write that equation out, so total equals 33 plus 43 plus 21 plus 52 equals 149, and then in MathSpace I can put my answer in. It then asks part B, determine the experimental probability as a percentage that a customer will order a beef meal, round your answer to the nearest whole percent. So a number of things are important there. Experimental probability, so we're basing that obviously on an experiment or some data that we've collected. It needs to be shown as a percentage, okay? And it also says the nearest whole percent. So those are three important parts of this question. So to work that out, I know that my denominator is going to be 149. That is how many possible things happen in this experiment. And I'm looking for the beef meal, which if I look here, 43 of those were beef meals. So that's the experimental part. So that is going to be equal to, so again, I can grab my calculator and I will do that calculation, which is 43 divided by 149, that's what a fraction of course is, and it says negative 106. I've done something wrong there, let me try again. 43 divided by, so I pressed the subtraction button on my calculator, 149 equals, now remember to turn a decimal into a percentage, we multiply by 100, so I'm just going to do that on my calculator, and I've got 28.85, although it says to the nearest whole percent. So if I've got approximately 28.85, let's say, then that should be a squiggly one, and then that's going to be rounded off to the nearest whole percent. So I'm looking at the whole numbers. So if I look at my first decimal place, that's an 8. So rounding that one would make it a 29 because the 8 would round up. There we go. So my answer would be approximately 29%. So I should be able to answer 29 in there. I forgot to put the percentage sign, and that's a very good point there. If it doesn't show it at the end, like it sometimes does, then of course you should include it. There we go. So probability equals 29%, and I have that question correct. Moving on. The traffic light in a town going north to south, the green light is on for 27 seconds, then the yellow light lasts for 3 seconds, and then the red light for another 20 seconds. This cycle then repeats. If a car approaches a traffic light, what is the likelihood that the light will be green? Okay, so in any moment of time, how often base is the light green? So again, if I have a look, my total is going to be 27 seconds for green, 3 seconds for yellow, and 20 seconds for was it red? So my total, I'm just going to put T is equal to the 27, sorry about my writing with a mouse, plus the 3 plus the 20. I don't need my calculator for that. I can simply say that is 50. Okay, so my probability of a green is equal to, from my experiment, the green is on for 27 seconds, so that's going to be 27 over 50. So 27 seconds it is green out of the total 50 seconds that the light process is going. And then if I use my calculator to get that, so I'll grab my calculator here, and that is 27 divided by 50. That's 0.54. Does it say how we have to present this? If the car approach what's likelihood will be green, probability is 0.54. Let's just put that in. 0.54. It's happy with that. Remember, when we are doing probabilities are listed between 0 as impossible up to a value of 1 being 100% going to happen. So unless it tells you to show it some other way, such as the previous question where it was a percentage value, you would expect a value between 0 and 1. So a fraction, or sorry, a decimal, that we have here, 0.54, seems correct to me. For yellow, well, we've already got some of that there. For probability of yellow, all right, yellow in this case is happening for 3, all right, out of the 50. So again, if we get our trusty calculator back, 3 divided by 50 is 0.06. So that probability is 0.06. Put that in. And finally, the red. So the probability of red, that's the worst writing ever, my apologies. And that would be for 20 seconds. So 20 over the 50 is equal to, again, trusty calculator comes in, 20 divided by 50, and that is 0.4. Okay, now one thing to notice here is if we have got the probability of every possible action, so we've got the probability of the greens, the probability of the yellows, and the probability of the reds here, they're the only things that can happen. If we were to add those probabilities up, they should equal 100%. And we can see that if we add 0.06 to 0.54, that is 0.6, and add the 0.4 there, then that would give us a whole, or 1, and that means we've got every option covered. So just a little check that you could do sometimes to see whether you have covered all of the options. Let's just look at one more very quickly. We'll have a look at this one here. An insurance company found that in the past year of the 2025 claims made, the 2025 claims, 1,192 of them were from drivers under the age of 25. Give your answers to the following questions as percentages, so that's important, and they're also rounded to the nearest whole percent. So again, this particular question is telling us how we have to present it. So what is the experimental probability that a claim is filed by someone under the age of 25? Well, we know the total amount is 2,025, so already we know that our denominator is 2,025. Okay. And it's told us that 1,192 of them were for drivers under the age of 25, and that's what is asked for here. So 1,192 were drivers under the age of 25. So we should really have PR of under, I'm going to put less than, actually, less than 25. Okay. Equal. So that's what I should have in my book, something like that. Bring back my trusty calculator. 1192 divided by 2025 is going to be 0.58. Multiply that by 100 to show it as a percentage. So you get 58.86, but it wants us to round that to the nearest whole. So like before, 0.8 rounds up, so I end up with 59. Now I'm not going to make the mistake this time. I'm going to remember to put my percentage sign in. So 59%. Press enter. There we go. What is the experimental probability that a claim is filed by someone 25 or older? Now this is interesting, and I wish I was planning to do this, but I honestly didn't. If you remember, just before I talked about that if we have had every possibility, our overall probability needs to equal 1. we found a probability of 59% is going to be under 25. So everyone else is 25 or older then. So we should be able to expect our result here to be approximately 41%. Now, I'm not going to straight away put 41 in. And the reason for that is we just did some rounding to get to 59. But I'm pretty confident it's going to come out at 41%. But let's do the math properly first. So the probability, okay, of greater than 25, or great, actually should technically be greater than or equal to 25, right, is going to be, now still going to be over 2025 because the total hasn't changed, but we need to work out what this number at the top is. We know what the under 25s are. We know what the total is. If we take the unders 25s away from the total, that gives us what was left. So again, bringing in our trusty calculator, clear that answer. 2025 minus 1192 means that 833 of the claims were drivers 25 or over. Okay, so we now have a number to use on the top. So that is 883. Again, let's bring back the trusty calculator and divide that number by 2025, which gives us a probability of 0.41, but we want a percentage, so we'll multiply that by 100. And again, let's round it to the nearest whole number. So the 1 rounds down, meaning this 41 stays as 41. So as I predicted from earlier, it's going to be equal to 41%. Okay, so if I come back to my math space, 41%, not forgetting that sign, and as I already predicted because I've worked out the other half of the probabilities, 41% plus 59% gives us 100% or a whole, and that is all of the possibilities that we could have in this experiment. So we were able to confirm that with the math. So there's 3 questions that we have done that help you to practice some of your probability. You can continue on with the rest of them that have been assigned to you.